Shouting at you from West Virginia, or from somewhere. Okay, I know that you're ready for joke of the day, so let's get that going. What do you call a dentist who can't stop working on teeth? What do you call a dentist who just can't give it up, can't stop working on teeth? An obsessive compulsive. You know, play on obsessive compulsive, but this is an obsessive compulsive. Okay, well, let's get compulsive about logarithmic functions. We're going to take a look at examples of being able to evaluate our logarithmic functions. We know how to translate logarithmic functions into exponential functions. We know some of our properties of logarithmic functions, that oftentimes the base and the number on the inside will cancel out. If they are the same, they will cancel out, and then they will give you the exponent of that base will be your answer. This previous video showing all these properties of logarithms. But what we're going to do is we're going to evaluate each of the following logarithms without using a calculator. Now, don't have a heart attack. Put that calculator away. You've got a great calculator right here. We're going to be able to use this calculator because we know how to rewrite logarithmic functions. So what we're going to do is we're going to say, okay, this says evaluate log base 12 of 144. Now remember, in order to rewrite it, we always say, and that's the best way to evaluate these is to rewrite them. And we always say base to the outside power. Well, it doesn't look like there's an outside power. So what I'm going to do is I'm going to turn this into an equation. I'm going to say this equals x. So now I do have base to the outside power, so 12 to the x equals the number on the inside, 144. Now we know that 144 is 12 times 12. Well, if that's the case, then that means that 144 is 12 squared. And notice that these bases are the same. If the bases are the same, what has got to be true about those exponents that you see up there? Absolutely. That x has got to be a 2. And so that gives me my answer of x equals 2. So in other words, log base 12 of 144 is going to be a 2. Now there was one of those properties of logarithms that we had that said if this 144 is going to be a 12 squared, we said these 12s cancel out, and the exponent that's sitting there, that is going to be your answer. And that's exactly the answer that we got. But notice that if you cannot remember this properties of logarithm, then we can just rewrite it and we can get to that answer as long as these bases are the same. So let's utilize that in evaluating this one. Once again, we could use this property of logarithms, but if we can't remember it, it's okay. Because what we're going to do is we're going to say base to the outside power, and it doesn't look like there's an outside power, so I'm going to turn this into an equation like this. And so now it's going to be base to the x, because when I evaluate this, I'm just trying to figure out what is this. It is whatever that number is going to be there. So it's okay to turn it into an equation in this manner. So base to the outside power, 9 to the x, equals the number on the inside. And once again, as long as these bases are the same, these exponents are going to be the same. Remember that 9 is 3 squared. So therefore, this is going to be 3 squared, and it's going to be 2 times x. Now this is 3 to the first power. So therefore, like we said up there, if those bases are the same, and they are the same now, then that means that these exponents here have got to be the same. So that 2x has got to be a 1. Which means I need to divide both sides by 2. And when I divide both sides by 2, I get a 1/2. Think about this. If you take 9 to the 1/2 power, that indicates square root of 9. Well, what is the square root of 9? It's 3. So it makes sense. In addition, going back to one of those properties, this property of logarithms, that these will cancel out. Think of it this way. This 9 is going to be 3 squared. And so those 3's will cancel out, giving you the 2. Now, let's try this one out. So in this one, once again, base, which is an understood 10, to the outside power. I don't know what that power is, so I'm going to call it an x. So I have 10 to the x equals the number on the inside, 10,000. And here again, 10,000 is going to be 10 to the 4th power. And now those bases are the same, and when those bases are the same, then that means those exponents have got to be the same. So therefore, that x has got to be a 4. Meaning that log of 10,000 is simply going to be a 4. All right, let's try another one down here. So we've got natural log of e to the negative 1 power. And we want to know what is that. I'm going to rewrite it. And when there is a cursive ln, that's natural log. Remember, that is an understood base of e. So I'm going to rewrite it as base to the outside power. It doesn't look like they're 1, so I'm going to turn it into an equation. E to the x equals, and it equals the number on the inside. That number on the inside is going to be e to the negative 1. Here again, those bases are the same, and when those bases are the same, these exponents have got to be the same. So therefore, that x is going to be a negative 1. Meaning that natural log of e to the negative 1 is a negative 1. Now, remember the rule here that when the base and this are the same, they will cancel out. That exponent is going to be your answer. The base and this are the same. They're going to cancel out. That exponent is my answer. Similar thing happened here. That 10,000 is 10 to the 4th. So if I would rewrite it in this logarithmic form, I would have log base 10 of 10 to the 4th. So those will cancel out. 4 is my answer. So like I said, you could go back to those properties that we had just discovered in the previous video, or you could just write it all out as I'm doing, translating into those exponential forms. So let's go with that again. Evaluating natural log of square root of 1 over e. So I'm going to rewrite it as base, and remember when it's natural log, it's an understood base of e to the outside power. I don't know what it is, so I'm going to call it x. So I have e to the x equals that number that's on the inside, that square root of 1 over e. Now remember, square root is going to indicate 1/2 power. So this is going to be 1 over e to the 1/2 power. But notice that if I flip this to be just simply an e, flipping indicates negative exponent. So that would be e to the negative 1/2 power. Now those bases are the same. And when those bases are the same, then those exponents have got to be the same. So therefore, that means that my x is going to be a negative 1/2. So that means that when I evaluate natural log of square root of 1 over e, it's going to simply be a 1/2. And if we go back to those properties of logs, then this is going to indicate log base e of e to the negative 1/2 power, because again, this is square root. Square root indicates 1/2 power, and in order to get a base of e, I'm going to flip it, and that indicates negative exponent. And here these are canceling out, giving me negative 1/2 as my answer. But once again, if you cannot remember that property of exponents, you can rewrite it and get there. So let's try this one out. Notice I've got that property that says these will cancel. My answer better just be a 21. That ought to be it, because these should cancel. But let's go with this base to the outside power. I don't know what it is, so I'm calling it an x. 2 to the x equals, and it equals the number on the inside, which is 2 to the 21. There it is. And remember, when the bases are the same, these exponents have got to be the same. Yep, that gives me the 21 that I thought was going to happen. So when we evaluate log base 2 of 2 to the 21st power, the answer will just be a 21. So now let's try this one out. Remember, base to the outside power doesn't look like it's there, so it's going to be a 14 to the x equals the number on the inside. Well, anything at all to the 0 power gives me a 1. That tells me that that x had better be a 0. And remember, that property said that whenever I have a 1 sitting here, then my answer is going to be just a 0. Review that previous video. Yep, that's going to be a 0 right there. Now, let's take a look at this one. Here again, base to the outside power. I don't know what it is, so I'll call it an x. 9 to the x equals the number on the inside. Bases are the same, so those exponents have got to be the same. But what is the exponent on this one? Yes, it's understood to be a 1. So that is how I get x to be a 1 in this case. In other words, when I evaluate log base 9 of 9, it is just a 1. Remembering this idea here, that these two numbers are the same, they're going to cancel out, but the exponent on the 9 is a 1. Therefore, my answer is just a 1. And let's try this last one here. Remember, if I'm going to rewrite this, it's currently in exponential form. If I'm going to rewrite it in logarithmic form, that would be log base. The base is 10. So 10 to the outside power, there's the power. Log of cube root of x. And that's going to equal the number on the inside. Well, I don't know where that number is. I'm going to call it a y. I can't call it an x because I've already got an x. So what happens here is, notice that in this one, it doesn't look like there's a base. When it doesn't look like there's a base, remember it's an understood 10. So I have log base 10 in both cases. So that means this y here, it has got to be this. The y has got to be a cube root of x. Now remember, I want to know, and that's just it right there. Cube root of x is the evaluation of that, which goes back to that property that said when this number, the base, and that base, when the bases are the same, that all cancels out. This right here is what your answer is. That cube root of x is it. So I hope that helps with this idea of being able to evaluate your logarithmic functions, either using those properties that we discussed in the previous video, or just simply being able to translate it into that exponential form, understanding when bases are the same, your exponents have got to be the same. I hope it helps. Have a great day.